The story of 3D printing begins in the early 1980s. Dr. Hideo Kodama of Japan was the first to invent a rapid prototyping system. However, it was Charles Hull in 1986 who invented the first commercial 3D printer. Hull developed a method called stereolithography, which allowed designers to create three-dimensional objects from digital data. His invention paved the way for the 3D printing revolution. In its infancy, 3D printing was primarily used in industrial settings. It was a novel way to create prototypes quickly and efficiently. Companies used these prototypes to test designs without the lengthy process of traditional manufacturing. Although the technology was groundbreaking, it was expensive and limited to large corporations and research institutions. Over time, 3D printing technology evolved. As patents expired, more companies entered the market. This competition drove innovation and reduced costs. By the late 1990s, 3D printing was no longer a tool just for big businesses. It was beginning to capture the imagination of hobbyists and small businesses. The shift from industrial use to more widespread applications was significant. As people began to see its potential, 3D printing started to infiltrate various sectors. This shift marked the beginning of a new era, where anyone with a 3D printer and a bit of creativity could transform ideas into reality. How does a 3D printer work? At its core, 3D printing is an additive manufacturing process. This means it creates objects by adding material layer by layer. The process begins with a digital file, which is essentially a blueprint of the object you want to create. This file is sliced into thin horizontal layers that the printer will follow. A common type of 3D printer is the Fused Deposition Modeling, or FDM, printer. It works like a very precise and controlled hot glue gun. The printer's nozzle heats and melts a plastic filament. The nozzle moves along the printer bed, depositing the melted plastic to form each layer. Once a layer is complete, the printer adds the next layer on top, slowly building the object. Printers need materials to work, and these materials have expanded far beyond plastics. Modern 3D printers can use metals, ceramics, and even food ingredients to create diverse objects. The versatility of materials has helped expand the technology's applications across different fields. Understanding how 3D printers work is crucial to appreciating their potential. The technology allows for complex and intricate designs that traditional methods can't achieve. This capability opens doors to endless possibilities in various industries, from healthcare to architecture. Once confined to factories, 3D printing has found its way into schools, homes, and hospitals. This transition has been driven by decreasing costs and increasing availability. Educational institutions have embraced 3D printing as a tool for hands-on learning. Students use printers to create models for science projects and art classes, bringing theoretical concepts to life. In homes, 3D printers are becoming as common as microwaves. Enthusiasts print everything from household items to personalized gifts. The do-it-yourself culture thrives on 3D printing, with countless online repositories offering free designs for users to print at home. This accessibility empowers individuals to innovate and customize their world. Hospitals have also seen a significant impact from 3D printing. Surgeons use printed models to plan complex surgeries, improving precision and outcomes. Customized prosthetics and implants are becoming more common, offering tailored solutions for patients. The ability to produce medical devices on demand is transforming healthcare. This democratization of technology is one of the most exciting aspects of the 3D printing revolution. It shifts the power of creation from centralized industries to individuals and communities. As more people gain access to 3D printing, the potential for innovation increases exponentially. 3D printing has already made a remarkable impact in various fields. In medicine, it has revolutionized the production of prosthetics. Custom-fitted prosthetics are now more affordable and accessible. In one notable case, a 5-year-old girl received a 3D printed arm, allowing her to perform everyday tasks with ease. The construction industry is also seeing a transformation. Entire houses have been printed using concrete 3D printers. These homes are constructed quickly and at a fraction of the cost of traditional methods. In developing countries, this technology offers a solution for affordable housing, addressing the global housing crisis. In the art world, 3D printing has opened new avenues for creativity. Artists create intricate sculptures that would be impossible with traditional techniques. Museums use 3D printing to replicate artifacts, allowing people to experience history without damaging original pieces. This blend of technology and art nurtures a new form of expression. The future of 3D printing holds immense potential. It could lead to advancements in personalized medicine, sustainable manufacturing, and even space exploration. By embracing this technology, we can address some of the world's most pressing challenges. To harness its full potential, we must support science and innovation. We invite you to join us at Ames Lab, where we explore the wonders of 3D printing and beyond. Subscribe to our newsletter for the latest updates and insights. Together, let's shape a future where science and creativity thrive. Written, directed, and produced by Ames Lab.